with that, we're going to bring on our MC Robin to introduce us to the next talk. Thank you so much, and we hope that you enjoy all that PyCascades has to offer for this, our second day.
Hey everyone, my name is Robin Lundeen. I'm joining you from Bozeman, Montana, and thank you so much for joining us today. I know from seeing people's comments in chat yesterday that we have people joining us from all around the world, so it might be morning where you're at, it might be evening, it might be middle of the night. We really appreciate your commitment. Today we have a talk from Rodrigo Girão Serrão. I hope I'm pronouncing that correctly. And Rodrigo started programming because he's always been fascinated by problem solving. Is that right, Rodrigo?
Yes, it is.
Awesome. Me too. I started programming in a boot camp, so shout out to all my boot campers out there. Rodrigo also enjoys fantasy books, comedy, movies, and eating chocolate. So if you're looking for a conversation starter, those are good ones. Now today in Rodrigo's talk, he's going to be talking about 50 Shades of Sine. We'll be going over a dozen implementations of a very simple function. As we listen, we're going to learn how to decide which alternative of implementation is best for this type of function. And we'll also be exploring some intricate Python subtleties. All right, take it away, Rodrigo.
Thank you very much. Thank you for introducing me. Hello, everyone, and welcome. I'm Rodrigo Girão Serrão. That's how you pronounce my name if you speak Portuguese, but it's fine. You can just call me Rodrigo. I know that's easier. I'm joining you from Lisbon, Portugal, and it's definitely not early in the morning, so if I feel like I have too much energy, it's because I have. So before jumping straight into the talk, I just want to tell you a little bit about myself. You already know most of the key things. You know my name, you know how I look, you know I like chocolate. I just want to tell you that my formal education is in mathematics. I have a master's degree in applied maths. But like you were told, I enjoy programming because I really appreciate solving problems, and programming does help a lot in that. I have been writing Python code for 9 years now, and I spend most of my time training and teaching APL for a company called Dialog Limited, and I also do some Python training on the side in my own, I'd like to call it free time, but it's not really free because I use it. So yeah. Also, I'd like to extend you an invitation to follow me on Twitter, where I share plenty of Python knowledge and where I will be dropping all of the relevant links for this talk. So the talk slides, the reference articles, the written version of this talk, I will share them all when this is over on Twitter. So feel free to follow me. All right, let's dive right in. 50 Shades of Sine. I have to tell you a little story, a short story about something I was doing the other day. So I was writing some code, like most programmers do, and I ended up needing the sine function. And for those of you that are listening but not seeing, it's not sine as in sine and cosine, it's sine, S-I-G-N, related to numbers being positive or negative. So I needed this function. I won't bore you with the details of why I needed it, so let's just accept that I needed it. And like any good programmer would do, I looked for it in the Python standard library, and specifically I went to the math module and I hit Ctrl F and searched for the word sine in there. And actually I found a bunch of occurrences of that word and a couple of functions that were related to signs of numbers, but this function itself was not there. And the sine function I'm talking about is this function that's usually presented in a way similar to this one in the maths world. It's a function that takes a number as an argument and returns one of three numbers. It's going to return a -1 if the input is negative, it's going to return a 0 if the input is 0, and it's going to return a 1 if the input is positive. So because I couldn't find it in the standard library, I had to implement it myself, right? And so what did I do? Well, this pretty much speaks for itself, so it's easy to guess what an implementation of this function could be, and that's what I did. I wrote it like so. Now, I just want to point out that I reordered the branches because I enjoy having the symmetry of x greater than 0 and x smaller than 0 here. I feel this is more balanced, and so I just shuffled things around a little bit. So I wrote this piece of code, And then I tested it thoroughly, because that's what good developers must do, right? So I tested my function thoroughly, and I saw, well, it does look like it's working. There's a positive number here, and the output is 1. There's the 0 there, and the output is 0. And here's a negative number, a negative float, and here's the -1. So I tested my function. I was feeling pretty good about myself because my function is working. But then I stopped for a bit, because sometimes I just get too carried away, and I looked at it and I noticed, well, how come I have 9 years of experience in Python and my code looks like it was written by a beginner? Why does it look like... Does it mean I'm not evolving? Have these 9 years meant nothing? Have I not evolved at all? And I was left wondering if this really means I have not learned anything. And I thought, well, no, I'm going to prove that I know what I'm doing. I'm going to write this in a better way, and I'm going to make use of more Pythonic features. So let's see what I can do. And so I was taking a look at the 3 branches, and I thought, well, I can't rewrite this as a conditional expression, because I have 3 branches here, but maybe I can chain 2 conditional expressions and rewrite this. And so I moved a couple of things around, and I wrote the function like this. And you can see here, just to make it absolutely clear, there's one conditional expression that's starting here. I'm going to return 1 if x is greater than 0. Otherwise, I'm returning -1 if x is smaller than 0. Otherwise, I'm returning 0. And I kind of enjoyed what I just did. But if you notice, I literally just moved things around. And I think this animation shows it pretty well, right? I just moved things around. So the essence is still pretty simple. It's just 3 branches and a couple of conditions to pick which branch I should return. And I thought that maybe this was still too basic, and I'm just air quotes here, so maybe too basic. So maybe I can do something else. Maybe I can do something more interesting. Maybe is there something more Pythonic I can do? And I needed some inspiration, so I started moving the branches around, and I decided to try checking if x was equal to 0 first, just to see if I could come up with something else. And then I remembered watching a talk at DjangoCon, and at that talk the speaker mentions the truthy and falsy values of objects. And the truthy and falsy value of objects, that's a Python feature that I find quite interesting actually. And it just tells you that most Python objects can be interpreted as booleans when need be. And in particular, numbers can be interpreted as booleans. Now what you can do is you can use the built-in bool to force this conversion to see explicitly what each thing is interpreted as. And what we see for numbers is that, now obviously the examples here, they're not exhaustive, but for numbers, positive numbers, they are all converted to true. The number 0 is converted to false, and all negative numbers are converted to true as well. So that's how the truthy and falsy values of objects work for numbers. Now with this information, what I can do is I can look at my double conditional expression, and instead of checking if x is equal to 0, maybe I can check if we don't have x. So what I'm saying now is that I return 0 if not x. Otherwise I'm returning 1 if x is positive, otherwise I'm returning -1. So this was something else I tried, right? And I was looking at this and I thought, well, maybe this isn't the best thing ever. Maybe this if not x really isn't great here. It may look confusing because in here we are kind of treating x as a boolean, but here we clearly are treating it as a number. So let's try shuffling things around again, see if we can come up with something else. And so what I did was, well, since we're starting with the x equals 0 here, let's really treat it as an edge case. Let's handle it separately. Let's start by checking if x is 0. And if it is, well, obviously we return 0. And if it's not, we'll use our conditional expression to decide whether we should return 1 or -1. So I rewrote the function like this. But now there's something else I want to talk about. And this is a slight nuance that I'm about to discuss. So some people don't care about this, but I probably have too much time in my hands, so I care about this, and that's just the semantics of what I'm trying to do. I said I want to treat x equals 0 as an edge case, in the sense that it doesn't really abide by the general rules of the function, or in the sense that it's something that I don't expect to need to handle that often. You can interpret my words as maybe x equals 0 isn't really going to happen that often. So we handle it first. And if it's an edge case, it doesn't make much sense to separate the juicy part of the function with an else, because the if else is putting these two options more or less at the same level, giving them the same importance. So what I did was I decided to remove the else. So like I said, it was just a small thing, but I rewrote it like that. And when I did, and that's why I often go through the trouble of doing small changes, because one change reminds me of something else. When I rewrote the function like this, I remembered looking at the Wikipedia article on the sine function, and in there, it's not a long article so you can find it easily. In there you can see that the sine of a number can actually be computed for all numbers except when the input is 0. But that's great because the input when x equals 0 is already being handled, so instead of a condition here, maybe we could compute the sine of the number. So how do we do that? Well, we just need the absolute value function, which is a built-in. So this ABS built-in returns the absolute value of the argument, and for positive numbers, that's just the number itself, and same thing for 0. The absolute value of 0 is 0, but for negative numbers, it's going to be the symmetric. So the absolute value of a negative number is going to be minus that number, which ends up being positive. Now, like I said, x equals 0 is already being handled, so we don't need to worry about that. We only need to worry about positive numbers and negative numbers. And when we get negative numbers or positive numbers, if we take the absolute value and we divide it by the number itself, take a look at what we get. If we divide a positive number with its absolute value, we get a 1. And for negative numbers, we get a minus 1. And these are the signs that we need to return. So, what do? We go back to the function we have. We handle x equals 0 as an edge case, fine. But then, instead of using a conditional expression to pick between 1 and minus 1, we use a division to compute the sign. And I find this interesting when compared to the couple of versions we had before, because now we stripped out the else and the conditional expression here. So our code is flatter in the sense that there's less conditions. And I don't know if you're familiar with the Zen of Python, but the Zen of Python says, well, flat is better than nested. So maybe we are going in the right direction? Maybe. Well, I'm trying. Yeah, so this looks interesting. To be honest, I find it interesting. I personally have a personal preference for computing things when I can, instead of using conditions to pick the correct value or the correct results. But I don't find this the perfect solution. And one thing that bothers me is the division. I don't like doing divisions. I studied a bit of maths, and I studied a bit of like how floating point systems work, and it's just, I mean, it's ingenious what we did from the engineering perspective, but I really don't like the fact that we get all kinds of errors, and division in particular is kind of nasty. So I would like to avoid divisions if possible, or when possible. And in fact, in thinking about other things I could try and do, I remembered something else, obviously. Otherwise my talk would be too short. I remember that not only can numbers be seen as Boolean values, but Boolean values can also be seen as numbers, in particular as the integers 0 and 1. So the Boolean value true, when converted to an integer, gives 1, and the Boolean value false, when converted to an integer, gives 0. Why does this matter? If you look at these two values, these are two of the three values that the sine function returns. The sine function returns either a 1, a 0, or a -1. And we can see that we can use the integer conversion of a boolean to return 1s and 0s. So what do we need to do now? We need to handle negative numbers separately. So for negative numbers, we're going to return -1. We're going to use a condition. We're going to type that condition to do that. But for positive numbers and for 0, we're going to use the correct condition inside the int built in to return the correct value. Now what's neat about this is that we don't even need a condition, because like we've seen, positive numbers are truthy, and the int of true gives 1, and 0 is falsy, and int of false is 0. So what do? We go back to the function we have, but instead of having the division over here, which is really bothering me, what we can do is replace it with the bool. So notice that we are handling negative numbers separately. We do them first, and then we take x, we convert it to a boolean, and then we convert it to an integer. And what this bool of x is doing is more or less checking if x is greater than 0. That's kind of what's going on. You can look at it like that. So when x is positive, this is true, and int gives 1. When x is 0, this gives false, and int of false gives 0. So that's what we have here. Now, again, you'll probably find by listening to my talk that I'm a very peculiar person. And there's one peculiarity about this computation that I don't appreciate that much. And that's that in a sense, I feel like there's some redundancy going on here. And why do I say that? I say that because we start with a number, x, then we convert it to a boolean value with bool, and then we convert it back to an int. It feels like we are going in circles, and all of this just to map some inputs to the correct outputs. And then it struck me again. We're talking about mapping things. I want to map some numbers to some values. But dictionaries in Python, they're sometimes called maps. So maybe I can use, crazy idea, just bear with me, maybe I can use a dictionary to map this type of condition that we have here. So maybe I can use a dictionary to map this kind of condition to the correct result, instead of having this weird thing going on where I'm converting things to booleans and then from booleans to integers. So maybe I can do something about it. And so, well, I tried it out, and I ended up writing this. Now, what's going on here? There's a conditional expression. That's the main thing going on. And the conditional expression checks for 0, and if we have a 0, then we just return 0. So there's the edge case there. And otherwise, we check, or we compute, or we use a condition to see if x is greater than 0. Because if it's not, we want to return -1. But if it is, we want to return a 1. And I'm not going to lie to you. I had some fun writing this. But at the same time, it looks a bit weird. I'll be honest with you, it looks a bit weird, and most of you will probably agree. Like a dictionary literal here that's being accessed when it was written, and the false and the true. This honestly just looks weird. But this enabled me to think of something else. Because if you look at it, well, let's do it step by step. There's something here, fine. Then we have a false to -1 and the true to 1. Now, the first thing I wrote was the -1, and the second thing I wrote was the 1. But in Python, if you're doing indexing, the first index is 0, and it's going to be associated with a -1 here, and the second index is 1, and it's going to be associated with this one. But if you've been paying enough attention, and if you've had coffee already, you will have understood that false is related to 0, which is the index I said. Gosh, my pronunciations today are just killing me. False is related to 0, and 0 was the index I said was related to -1. And true is related to 1, which is the index I said was related to this here. So what we can do is we can get rid of the dictionary, we can just keep the values and write this as a list and indexing. And then let's just put it on a single line because it's short enough. Isn't this interesting? Like, honestly, writing this, I felt like this was very interesting because this is just a Boolean value, but I'm using the Boolean value to index into a list. And this is essentially replacing like a whole conditional expression or an if-else statement. So I find this to be very interesting. But then, if this made me somewhat happy, then this makes me somewhat sad. Because like I said, I'm very peculiar and I like computing things when I can. And that also means I like to avoid edge cases when I can. I tend to prefer an overall, let's say formula. When possible, I prefer to have like a big formula that takes care of everything, of all the cases, of all the situations. So it's kind of sad that I'm doing this funny indexing over here and then I have to handle x equals 0 separately. Or do I? Is there nothing I can do here to take this and put it inside the list in some way? Well, much for my joy and perhaps for your sadness, I can do something about it. I can write the list with all 3 values I care about. I care about -1, 0, and 1. And then I can use 2 conditions to index into the list. Now, what's going on here? When x is positive, this condition gives true and this condition gives true. And so true plus true is going to convert the booleans to integers, and so we're going to end up with 1 plus 1, which is 2, and in this list, index 2 points to the 1, to this number right here. When x is 0, this condition is false, but the first condition is true, and so true plus false is going to give 1, and index 1 points to the 0. And when x is negative, both conditions return false, or evaluate to false. I should be saying that. Both conditions evaluate to false, and false plus false gives 0 plus 0, which is 0, and the index 0 is going to pick up the -1. So that's quite interesting. There's no edge cases. I'm covering everything with 2 conditions. And at the same time, it's not necessarily the best criteria, but this has been the shortest solution so far. And naturally, I thought, well, is there something shorter? And there is. And I can create something shorter by looking at the 2 conditions and realizing that I'm using sort of Boolean arithmetics to do some computations with 2 conditions. And if I pick the correct condition, I can write something as short as this. And I find this amusing. If you look, you have to step away enough from the screen to see this, but this looks kind of an emoji. There's the eyes are these 2 sets of parentheses, and this is a nose or maybe the mouth. I'm not sure, and well, it's a nice emoji. It's the Sine emoji. And how does this work? Well, it's very similar to the previous one. It's just a matter of realizing that these 2 conditions, they can be false at the same time, but you can't have both of them to be true at the same time. And so the way this works just boils down to understanding the patterns that come out of evaluating these 2 conditions at the same time, which are, they're the same conditions, x greater than 0 and x smaller than 0. So we have these 2 conditions here. And we just have to understand which ones are true and false depending on, well, the sign of the number. So we can unfold them, and these are the 3 patterns we can get. When x is positive, we get a true false. When x is negative, we get false true. And when x is 0, we get false false. And putting a minus sign in here, we're going to get the 3 outputs. But now, this begs yet another implementation, because I was talking about patterns, and I'm not sure if you're already familiar with it, but in Python 3.10, you got the match statement, and the match statement is great to match patterns. So can we try this here? Can we try using a match statement? Well, with all you've seen me do, of course we can try it here. So let's try it. We're going to match on the pattern that these 2 conditions take, and, well, depending on each case, we're going to return each number. Right? This is just, I'm being a bit redundant, but it's what's happening here. But when I wrote this, I wasn't very pleased with the result because I don't really like having these 6 booleans here enumerated. I don't find it very elegant. So maybe we can make this lighter on the eyes by using guards instead of explicitly writing down the cases. So now what we can say is that we're matching x, and we're going to match over here the x if x is positive, or we're going to match the x over here if x is negative, and otherwise the fall through, the default is going to be to return a 0. But now, we've gone through all this trouble, we've gone through so many implementations, we've just circled back to the beginning, because if we strip this function away from what's not needed, we just end up with something that looks very similar to what we had in the beginning. Except that in the beginning we had if, elif, else, and now we have if, and just a bare return. But what we can do now is we can take a look at the this module, and this meaning dis, the first 3 letters of disassemble. We can take a look at the this standard module, and we can ask it to show us what Python compiles these to. So can we look at the internal, let's say, internal representation of this function? And Python gives us this, and it's okay, you don't need to understand this. Just notice that when I change slides, I changed this to the very first implementation we have, and the output that Python gives us is essentially the same. Just look at the right. The bytecode is exactly the same, except that we have 2 blank lines. But in terms of functionality, the blank lines mean nothing, so these 2 functions are the same for Python, which I find quite interesting. Now, we've gone through 15 shades of Sine, because I wanted to see which implementation I was going to pick and which one was best and more Pythonic, and which one would show that I have 9 years of experience. But I just ended up being very confused. So I decided, well, maybe I'll try timing all these different approaches and I'll pick the fastest one. I'll try to do that. And so I did some basic timing, and you have this nice table over here. And at the top we have the fastest one. And then these are relative comparisons to the first one. And I'm not going through the trouble of explaining this. This is just some basic timing I did. What I'll say is that these 3 functions that come next, these 3 rows, the timings are pretty similar to the one on the top. Green obviously means faster and red means slower, apart from the case when the input is 0, but that we don't expect the 0 to happen that often. And these 3, they have pretty similar timings, and I'll show you why. Because the last function we ended up with, and I'm pointing at my screen like you could see, the last function we ended up with, which we've seen is equivalent to the first one, that's also equivalent to the double conditional expression that we have. And this, or maybe this one, this was the one that I said was too simple, too basic for me, right? What I didn't tell you was that all of these functions we've seen, I didn't come up with them. I went on Twitter and I asked people to implement the Sine function in the best way they could. Like I explicitly wrote, what's the most Pythonic implementation you can think of? And people gave me this one, and all the others I showed, no one showed me this one. It was only like a day after I had published the original tweet that David Wesley, which is a very well-known Python author and trainer, that wrote, just basically said that no one was brave enough to write the simplest solution of all. And I guess the point is that there is elegance in simplicity, and there's no point in overcomplicating things. I know it's a fine line between using nice features and just overcomplicating things, but you have to be aware that sometimes being experienced or having experience means understanding that what's the most simple solution is also the best one. So that's what I had to share with you. I just want to say that there's a couple of articles that I wrote explaining some of the things we've seen, like conditional expressions. If you want to understand these, there's some references here, and the written version of the talk, I will also share it with you. These things that explain these features and how to use them in the proper way, you can find them on my free Python book. Again, no need to remember the links because I will post them on Twitter, which is probably the easiest way to get hold of all these links. And if you're not on Twitter, or if you don't want to follow me because I talk too much about Python and I don't share pictures of my puppies, because sadly I don't have any puppies, You can also subscribe to my newsletter. I'll send the links there. You can find me at mathspp.com, so that's easy enough. If all you want are the talk slides, you can find them on GitHub. And finally, I'll appreciate any and all feedback. You can drop me a line. I love meeting new folks. I love meeting everyone, so drop me a line and just give me your honest feedback so I can improve for my next talk. I hope you have a great day, and I hope this was helpful.
Thanks, Rodrigo. That was super informative. I love the reminder that sometimes the simplest solution really is the best one. I think it's a great lesson for us to all learn. We also learned that we need to start a campaign to get you some puppies. So if anyone wants to get Rodrigo a puppy, it sounds like he might be ready for one. Thank you for that. Oh, we don't know yet. I don't know. Once the puppy gets there, I think you'll like it.
Probably.
Yeah. So please join Rodrigo in our Q&A if you have any questions or you'd like to hear more about what he has to say about Python and our implementations of various functions. I believe we're going to take a 15-minute break now, so go ahead and get some coffee, water, something to eat, and then join us back here in 15 minutes. Thanks.